Hello everyone, welcome to the Programming Logic and Design Midterm Review. So here we have 10 items, 3 of which are for debugging and the other 7 are for flowcharting and programming. It's up to you if you want to do the flowcharting or the programming first, but personally I prefer doing the programming first. So for number 1, input-output. Ask the user to enter 3 integers, then display which is the largest. So when we enter 3 integers, um, we need to assign them to a number. So I'm just going to call them number A, integer, input. Please enter an integer. Okay. So the things you need to consider here. First, you need to assign it to a variable. Second, you have to enclose the input in int parentheses because the direction says enter 3 integers. And for the simplicity of this review, I won't be including any error handling unless the problem states otherwise. Okay, so now we have one number. Let's copy this code so that we can have 3 numbers. Make sure to change the number of uh, name of the variable as well as the message. So now that we have this, it's time to display which is the largest. So if you have something like this, you can just use the maximum function. So just put n. So just put the maximum parenthesis num a comma num b comma num c, and then you have to assign it to a variable. Okay. So here for the largest, we assign it to this variable, and then we print it. For simple code, you could just simply print largest, or you could use an f string to print it inside a sentence. So for example, uh, the largest value is the largest, and then you enclose it in curly braces. So let's see if this code works. Enter the first integer, I enter 7. Next I enter -13, and then I enter 4. So it should tell us that the largest value is 7, since this is negative and this is positive. So the flowchart for number 1 um, is going to have a start block, 3 input blocks, a process for the maximum, and then printing the output in the parallelogram. So first, we start with an oval, then we connect it to a parallelogram for the input. So we have input int num a. Since we have 3 numbers, we need 3 of these inputs. So sometimes we can do shortcuts. We can input them all in the same box. But for the sake of clarity, we're going to do it this way for the examinations. Next, we set it as the largest. So set largest as the max of num a, number b, and number c. We then print the largest. and then we end the program. So this is our flowchart for number 1. For number 2, ask the user to input a distance in kilometers. Calculate and display how much they will pay if the minimum fare for a traditional jeepney is 13 pesos for the first 4 kilometers, with an additional 1.80 pesos per succeeding kilometer. Round the fare to the nearest peso. Okay, so for this one, we need to start by inputting a distance. So let's have the variable distance and input. Please input a distance in kilometers. Um, and then the problem doesn't state that it is an integer, a float, or any kind of number. However, if you will be operating on inputs, you need to turn them into numbers first, because when you get them from the input, they will just be a string. So you need to make it a float. Then calculate and display how much they will pay if the minimum fare for a traditional jeepney is 13 pesos for the first 4 kilometers. So for the first 4 kilometers, you have simply distance times 13. However, if you have more than 4 kilometers, you would have uh, distance minus 4 times 1.8. This is the extra one, which is added to 52. So make sure to enclose it in the parentheses so that the correct order of operations is followed. So if you're wondering where this 52 came from, this is simply 13 times 4. So these will be your two computations of the fare. Now, when will you use them? So it says here, if it's just going to be 4 kilometers or less, you use fare is equal to distance times 13. Else, you have to use this formula. Lastly, round the fare to the nearest peso. So to save space, you can simply round it here. Or you could just round it outside. Set fare is equal to round fare, comma 0. So I prefer to put it in here. So round this to 0 decimal places. Okay, there is another way to display it without the decimal. That is to use a formatted string where you display it like this with the colon dot 0f. So let's start again. Okay, so now this is correct. So let's try with a higher value. What if we go 21 kilometers? Then the fare will be 83 pesos. So number 2, the jeepney fare. So first, we start it, well, after the oval, we start it by inputting the distance. And since we will be operating on this variable later, we have to turn it into a number. So it has to be a float. Next, we need to check whether or not the distance is less than or equal to 4 kilometers. So we need a decision block. distance less than or equal to 4, we're gonna have two computation blocks. So first, if the distance is greater than 4, we use compute fair as round 52 plus distance minus 4 times 1.8, and then comma 0. So make sure that every parenthesis has its matching start and end parentheses. And then the other side will be compute fair as distance times 13. So attach the flow lines to the side of this. So as much as possible, try to avoid having many bends. Try to keep it as minimal as possible. And ideally, it should be going downward. Next, we have to print. So we use the keyword display the fare. So in simple programming, it's only important to display the fare. But in the case of what I did, I'm going to display the entire thing. So earlier I typed the fare for distance kilometers is p fare 0f. Well, for the flowchart, the only thing you're going to need is this one. You need an f string because it's stated in the directions to round it off to the nearest peso. And also, I forgot here in the first one, we also need to round it to 0 decimal places. So when connecting the flowchart, the lines need to join each other first before they reach the shape. Then we end with a terminal block. And lastly, don't forget, we need to add the true or false text every time we have a decision. So this is true, and this other one is false. For number 3, make a loop that prints the perfect square starting from 1 squared in order until you reach a 3-digit number. Once you print a 3-digit number for the first time, stop the program. Okay, so there are a lot of loops that can be used here. Some of them have overlapping descriptions, like the do while loop and the while loop. And in some cases, you can also use the for loop. So in this case, I'm going to see which one is the best suited first. So if we want to print the perfect square starting from 1, we need to have a variable that tells us where we are starting. So let's have count is equal to 1. And then we need to compare the value of it, right? Since we're reaching a 3-digit number. So the value, we don't need it yet, but we initialize it to 0. So this is also the same as declaring it, except this time, instead of just declaring it, just letting the program knows it exists, we equal it to 0 or any other arbitrary value. So the thing I can see here is reach a three-digit number. To me, that sounds like we need a condition. So the three-digit number, that the earliest square we could get there is 100, right? And it just so happens to be um, a perfect square and the first three-digit number. So the condition I'm going to use is while. So while the value is less than 100, do the code inside this indent block. So while the code is less than 100, set the value to count squared. So in Python, the operator I use is the double asterisk. Since on some laptops and some versions of Pythons or IDEs, this is not recognized. Well, in others they are. So for the purpose of this video, I'm going to be using this. Value is equal to count squared, and then we have to print the value. And then to make sure that this does not loop over and over again without ever finishing, we need to increment the count by 1. So for example, the first time you run it, it will be value is equal to 1 squared is equal to 1. So it prints 1. Then the count becomes 2. Value is 2 squared, which is 4, and we print 4. Next, it becomes 3 squared equals 9, and you print 9, etc. So it's going to continue all the way until we reach a three-digit number. So once this condition is no longer met, we can quit the program. Now, depending on the given, you can actually quit it or break it inside here. But since the given says, once you print the three-digit number for the first time, stop the program. It means you don't have to interrupt the printing of the first three-digit perfect square. So let's see if our code is working. And as you can see, it does work now. We start with terminal block and then two processes to initialize the variables. So our first one is going to be count, uh, set count as 1. And then the next one is set value as 0. Next, so now while this condition is satisfied, we continue with the code. We compute the value as count raised to 2. Then we print the value and increment or increase by 1 for the count. So after this, we should loop around back here to the value. So we need to check the condition if value is still less than 100. So what we want to happen here is after it prints the first three-digit number, which is 100 here, it will not compute a new value anymore. It will just continue. So the last one in our code is the end. So since this is a while loop, this should be true. And then this one should be false. Next, for number 4, ask the user to input a string and display whether or not it has any vowels in it. Here's one way that we can answer this problem. So ask them to input a string. So the vowels in the English alphabet are A, E, I, O, and U. So notice that I used a for loop here. So the for loop is used to reiterate over ranges, sets, or other things where we know how many members there are. So for the vowels in A, E, I, O, U, this is going to run the code 5 times. So the thing that we want to do here is check whether the vowel being specified is in the word. So if the vowel is in the word, then we can set uh, we can set is vowel to 1. So this is 2. So I forgot to mention earlier, when checking something like this, it's a good idea to assign a variable to see whether or not it will be true or false. So for example, if vowel is in word, set is vowel to true. So any other value of A, E, I, or U, A, E, I, O, or U here will not affect this. So another way that we can do it is here. We can increment. So I prefer this one because we can know how many of A, E, I, O, and U we can have. So if the vowel is in the word, increment the is vowel by 1. So I'm just going to change this to a count to not make it so confusing. So after this, we don't need an else for it since there's no reason to stop this. The next one we can have is to display whether or not it has any vowels in it. So the next one is if count is greater than 0, we have to print this word has vowels in it. So another thing to consider is that capital A and lowercase a in Python are considered different things. So that's why here in our input, we have to specify that we want the input to be lowercase. So let's see. So let's test first with lowercase abc. So yes, this word has vowels in it. What about uppercase ABC? So here, the uppercase ABC is also accepted even if it's capital. And I want to show you how sometimes the flowchart doesn't translate exactly to the code. Because for here, since I used a for loop, for a vowel in A, E, I, O, U, this already combines a lot of steps and makes it look more elegant for the code. So if you're asked to simply write the pseudocode for it and you don't need to write the diagram, you could do it this way. However, if you're making a diagram and suddenly you find yourself stuck, if the um, if the main priority for the question asked is a diagram, you can restructure your code for it. This is another way to write this. So I'm going to follow this for writing the flowchart. Set vowels to, and then set I for the index to 0. Remember, we started at 0 because in Python, the start of this is going to be 0, 1, 2, 3, and then 4. Next, while I is less than the length of the vowels, if the vowels, the index of the vowels is in a word, or if the vowel itself is in the word, so if this is true, increment the count by, so if this is true, you increment the count by 1. And then regardless of whether or not it is true, you need to increment I by 1. And then this has to loop back to here. So take note, it's important to label it. So this one will be true. So if it's true, it will increment the count by 1, count of how many vowels there are. And then it will increment the index by 1. So it will go to the next vowel. So if this is false, it will skip um, incrementing the count of the vowels by 1. It will go straight to the next index, which is basically skip this vowel, go to the next one. So after that, we have another if statement. So if the count of the vowels is greater than 0, we can print this word has vowels in it. Otherwise, we can print This word doesn't have vowels in it. And then lastly, we have to end the program. So this is going to be our flowchart for number 4. Now, for the next few items, we're going to be focusing more on debugging for numbers 5, 7, and 8. Then for number 6, we're going to make it with code only first. So for number 5, this program is supposed to display the first n terms of the Fibonacci sequence as specified by the user. Fix the line of code that causes the sequence to print incorrectly. So the first thing you need to do here is, if you are um, given the input and the expected output, you need to check what it's supposed to do. So as you can see here, the expected output is, it will input it will output the first 9 numbers of the Fibonacci sequence. So 0, 1, 1, 2, 3, 5, 8, 11, and then 19. However, the output, it seems to get stuck on the ones. So let's see. This has 9 numbers, and this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this one has 11 output. So if you're familiar with the Fibonacci sequence, the first thing you notice is you need n minus 2 to start it, since the start of it is always going to be 0 and 1, and then the pattern continues from here. So that's the first thing. So you have to check here where it got wrong. So try. So let's add comments to clarify what this is. So this is the start of the program. Ask the user how many terms of the Fibonacci sequence to display. So if you see a try and accept value error, this basically says it can handle when a non-integer value is inputted. It will not crash the program. Next, if it succeeds the try and accept value error, it will go here to set the input as an integer. And then, if n is less than or equal to 0, it will already handle when the Fibonacci sequence doesn't work with negative and 0 terms. So this part is already free of errors. So let's go to the next part. So as we can see here, it sets two variables, the previous and the current one, because um, in the Fibonacci sequence, the sum, or rather, the term is the sum of the previous two items or two elements. So we start always with 0 and 1. So this is correct. And then we print the first n terms of the Fibonacci sequence. Now, let's take a look here. If n is greater than 1, then we print the current. So we can see here that they already printed 0, and then this will print 1. So basically, this is saying that if n is 2, then it will display 0 and 1. If it is 3, it will start with 0 and 1, and then continue the pattern. If it's only one term long, it will only display 0 and nothing else. So that's what this part is. Now, here is the first error. So as you can see here, for I in range n, this is the part that repeats. It is the part that has 0 plus 1 is equal to 1, 1 plus 1 is equal to 2, 1 plus 2 is equal to 3, and so on. So the main mistake here is the n has to be n minus 2. If you have access to a laptop during this, you can test it for yourself. So as you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the number of terms is now correct. However, this is still incorrect. So we can see here that it's stuck on the current value 1. So if you don't have a laptop with you when you're doing something like this, you're just given the plain text. What you can do is hand tracing. You have to trace the values of 0 and 1. Or you can also do it by visual inspection. So this one, you can see that the next item should be the previous plus the current. And we print the next one. So basically, we're at this part of the program. 0 plus 1 is equal to 1. And then, it does it again. However, as you noticed, we never actually changed which ones are the new previous and the new current. So instead of 1 plus 1, we're still stuck on 0 plus 1. So it just goes on 0 plus 1 again and again and again. That's why it's stuck at this. So to fix that, what we need to add is this. Set the previous one to the current one. And then set the current one to the next one. So basically, this moves this 0 plus 1 to here, 1 plus 1. So again, you can run the code if you have your laptop with you, or you could do hand tracing on paper. So let's see. The first, the first 9 terms of the Fibonacci sequence are 0, 1, 1, 2, 3, 5, 8, 13, and 21. So this is correct. Sorry for the typo. This is not supposed to be 19. This is supposed to be 21. Okay, so this is the correct output for number 5. So next, for number 6, we have to generate something now. A user is collecting a freebie from a fast food app. Ask the user if they want a snack or a drink. Then ask which one of the 3 snacks or the drinks they want. They can only pick one. Okay, so this one is going to be a nested conditional. Later, I'll show you what the flowchart looks like. But for now, let's work on the code. So if they're collecting a freebie from a fast food app, ask the user if they want a snack or a drink. So you have input. Please choose, and then we need a menu option so it's easier. Please choose 1 for a snack and 2 for a drink. Next, after they choose their freebie, um, remember that if they enter a number, it has to be an integer, and then it has to be assigned to a variable. So we call that variable as choice. Then ask which one of the 3 snacks or the 3 drinks they want. So this is going to be a nested conditional. So if the choice is equal to 1, this is for snacks. And if the choice is not 1, elif choice is equal to 2. This is for the drinks. And then we have else if the user enters something else. So let's start with elif choice is equal 1. So it's not specified which of the three snacks they want, so I'm just going to add some here. So prompt them again. Please choose your free snack. Number 1 is going to be apple pie. Number 2 is going to be fries. And number 3 is going to be a burger. So just like earlier, what you have to do is essentially make an if, elif, and else again. So let me just add the other choices. Okay. And then for the else, we need to print something. Please choose only one or two. Okay, now from here, we have if choice is equal to 1, print, you have selected, or rather, enjoy your free apple pie. And then we copy the statement and change it to elif. Then everything else is going to be between 1, 2, or 3. So let's change these. And then for number 2, we can simply paste it. And then change the items to soda and juice. So this is the most basic way to make a nested conditional. You can combine it with lists and even dictionaries inside for and while loops if you want to make a choice between a very large number of choices. So for this one, I'm going to assume that we don't loop the program and that we don't need to handle any errors. So this is what a nested conditional looks like in code. So I'm going to show you what the flowchart of it looks like. So here is the flowchart for number 6. So it's a bit long. That's because we have a lot of nested if statements. So if you notice here, um, this looks like another arrangement of this. So it's okay to bend the lines a little bit. It's okay to change the direction of where it's going as long as it's still readable. And this one, it is a vertical version of this one. So this, it's formatted this way so that it's easier to read. And then for convenience, you can also add connectors. So the connectors, they go to A and exit straight to the end. So that prevents us from drawing so many lines all going to the end at once. So for number 7, the high school faculty wrote a program to award their students based on the criteria written in their school handbook. Fix the code so that this student gets the correct award. So with high honors, we have a general weighted average of 92 and above with the lowest grade of 90. With honors has this general average of 88 to 91 with the lowest grade of 86. Then achiever has it with an average of 85 to 88 with the lowest grade of 83. So we have the provided data, and then from here, there is no expected output and there is no output. So first, before you make any changes to the program, you have to run it, or you have to hand trace it. You can manually compute the average of these grades. Okay, so this average is going to be something like 91.67. They don't fall in the criteria for high honors. So they should be for with honors. So let's see. The lowest one here is 87. So 87 is their lowest grade as shown here. And after double checking this, you can see that these parts are correct. These parts are correct rather. So there is no error to be checked here. Now you need to take a look at this. So as you can see, it perfectly follows the criteria here, except that's the problem. Or rather, a lot of the criteria that we are shown usually deals with whole numbers. So as you can see here, it says round the grades to 2 decimal places. So round the average. So when we get 91 point something, it's not actually going to fall anywhere here. So I'm going to run the program so you can see what I mean. So see, the average is 91.75. The lowest grade is 87, and then the award is none. So the reason that happened is because 91.75 falls exactly between 91 and 92. But if there are decimals and you're already using the if, and else, you don't need this part anymore. Because the only way you can get here after the average is greater than or equal to 92, if that doesn't pass, the next step you're going is the average is greater than or equal to 88. So this part is redundant. So remove it and remove this. You should see that it is now fixed. So sometimes it can be as simple as a logic error. Even if there are no syntax errors, sometimes you have to inspect the logic itself to understand what's going on. So for number 8, multiple if statements. This code asks the user to enter a password that is at least 8 characters long, has letters, and has numbers. It should display an error message for each error and reject the password if it fails any of these criteria. This password should be valid, but it triggered all 3 of the errors. Fix the code to reach the expected output. So the user inputted safe web 7. So again, let's hand trace, or at least let's see what's going on. So the only variable you have here is the password. So instead of hand tracing just the password, you need to see what's happening with the values of length of password, and the boolean here for password is alpha and password is numeric. So let's see, what is the code supposed to do? First, ask the user to enter a password. They entered safe web 7. So as you can see, it is 8 characters long. It has letters and it has a number. So it's not supposed to display these errors. So let's see what could trigger it. First of all, this one, if the length of password is less than or equal to 8. So this is the first error because it's less than or equal to. this should be only less than, because 8 is less than or equal to 8. So since 8 is less than or equal to 8, it's going to trigger this error. So this one should just be less than. So let's see. Let's compare it before and after. So see, this is before, and then this is after. So as you can see, the first error has been eliminated. So the second and the third errors still remain. So this one, if not password is alpha, then print the password does not contain any letters. However, this one, if you see, this is supposed to compare if the entire password is made of letters. However, we don't want the entire password to be made of letters. We want the letters to exist beside the numbers. So let's see how we can do this. So we need to apply the is alpha to every letter of the password. For letter in password, if letter, or rather, let's call it character. For character in password, if character um, is not alpha, we have to increment a variable. So let's see how many letters are there. Letters, we start with 0 letters. So we remove the not. If the character is alpha, or if it's in the English alphabet, we add it to the letters. So for every letter, it adds 1 to the number of letters. And then after it checks each character in the password, if letters are greater than 0, or rather, if letters are less than 1, print error. The password does not contain any letters. So as you can see, this part, the error has already been eliminated. So similarly, since this part was originally written the same way, we can just copy paste this code and then change the variables. So we check if each character is numeric, and if it is, we add it to numbers. So if the numbers at the end of checking each, so if the numbers are still less than 1, or if there are 0 at the end of this, actually wait, just want to write is equal to 0. So if there are 0 numbers at all, then we raise the error. Password does not contain any numbers. So if the length of the password is greater than 8, and password is alpha, and password is numeric, print your password has been accepted. So in the original code, these were supposed to be the success conditions. So these are the conditions where we do not trigger the error. So for example, the opposite of the length of the password being less than 8 in the old program was to be greater than 8. However, this is the first mistake. Since we do not since we do not want it to be to exclude exactly 8. So it has to be greater than or equal to 8. Because 8 is not less than 8, and 8 is at least 8 characters long. That's why you should not exclude it. Next one, we said this earlier, password is alpha, we don't want the entire password to be numbers and letters. We want, rather, we don't want the entire password to be letters, or we don't want it to be entirely numbers. We want it to be a mix of both. So that's why we will use the variables we used earlier. Letters. So if letters is greater than 0, so if earlier the letters equal to 0 causes it to fail, the letters being greater than 0 causes it to succeed. And we do the same thing for numbers. Then we print your password has been accepted. So this should be the end of it. Let's check if we did it correctly. Safe Web 7. Your password has been accepted. So we're finally done with number 8. Okay, so for number 9, determine if the number a user inputs is prime, compound, or neither. The program should still work when a non-integer value is entered. Okay, so here is the thing. If it should still work when a non-integer value is entered, we need to add try and accept. So basically, try and accept tells us that it will try something, and if it encounters an error, like a value error, it will switch to doing something else. So for example, if we try to turn the input of a user into an integer, it should look something like this. Please enter a positive integer, and then print is neither prime nor compound, since it is a non-integer input. So let's try this with Apple. So it's going to tell us that it's neither. So if we try this with a fraction or perhaps a percentage, it's also neither prime nor compound. So one thing that you can do is to write quit here, because if you just write the entire rest of the code here, it's going to be a lot of indentations inside. So it's better to just write quit here. And then the next part, so this one handles non-integer input. We know that it should not be negative and it should not be 0. So let's have this number. So if number is less than 2, or rather, let's have separate cases. Number is less than 0, we print neither prime nor composite. So negative numbers are neither prime nor composite. Next. So if the number is exactly equal to 0, wait, actually, if number is less than 1, instead of negative numbers, we can say non-natural numbers are neither prime nor composite. And then, if the number is exactly 1, we can write 1 is the only positive integer to be neither prime nor composite. So we can say that the start is going to be 2. And so let's name this as the check variable. And we only need to check until the square root of a number. So for example, if we're going to check if 6 is prime or composite, we need to check only until 6. So specifically, that's 2 3, 4, 5, and 6. Um, we try to save computing power. So instead of checking from 1 all the way to 36, you only check from 1 to 6. Similarly, the one I want to check is 41. So 41 is between 36 and 49. So what I want to get is 7 squared. Now, I also want to round up. And currently, we don't have that yet. So we have to go to the start and then import the math module. So simply import math. Next, we want to stop when we reach the square root. So the square root of 41, or the square root of the number that is inputted, we can put it as number double asterisk 0.5. And then we enclose it in parentheses. And then we use math.ceil since we want the ceiling of it. So we don't want to just round off. We want to be precise. We want to get the higher one. So now from check and stop, we have to check 2 until the value of stop. So in this case, it's going to be 7. So to check from 2 to 7, while check is less than stop, we need to check if the number the the number divided by check, if the modulo of that or the remainder of that is perfectly zero, that means it is divisible by something. So let's write uh, divisible by rather we don't need to check how many it is divisible by. We just need to know that it is not prime. So at the start, it will be prime unless there is something that makes it not prime. So again, with repeated computations in the real world, we want to save computing power. So we try to avoid unnecessary computations. We check only until the square root, and then um, we use booleans for this. So after checking all of the numbers, we need to make sure that it doesn't get stuck on itself. So check equals plus equals 1. So let's see, while check is 2, while check is 3, check is 4, while check is 5, while check is 6, and then when while check is 7. Okay, we need to add this. So I added a little bit of code to show you what's actually going on. So, and also I changed the sign from slash slash to percent, since the percent is the modulo in Python. So let's see what happens when we type in 36. As you can see, 36 is being checked from 2, 3, 4, 5, and 6. So it's divisible by 2, 3, 4, and 6. So 36 is composite since it has more than 2 factors. So whenever there is a 0 resulting here, it gets marked as not prime. And then you can break. So we need to break out of the loop early. Uh, we don't need the parentheses, you just need break. So it immediately terminates the execution of the innermost um, So it immediately terminates the execution of the innermost for or while loop that contains it. So let's see. So as you can see here, 36 modulo 2 is 0. So it does not need to compute any of the other ones after it. So this is useful when you're trying to save on computation space. So last one, when you let's try to see if it works for 41. So as you can see, none of the numbers from 2 to 7 are able to perfectly divide 41. So that's why 41 is prime. So now I can remove this part since I know that the program works. So lastly, number 10, user-defined functions. Import Python's built-in math module. So import math. Write a user-defined function that determines the area of a circle based on the given diameter. Then we use it to calculate the areas of the following pizza sizes. Small 10 inches, medium 13 inches, large 15 inches, and fiesta 18 inches. So in defining a function, we have to write def and then the function name. So I'm just going to call it area. And then inside it, you need a parameter. So the parameter is the value that you need to make it work. So I'm just going to call it diameter. So the area of a circle based on its diameter is pi r squared, or simply pi times the square of d over 2. So to do that, I'm going to write this find area diameter as return value of pi math.pi times the square of the radius, or what is simply the diameter divided by 2. So I'm going to check with my calculator if it works. Print the area of 13. So this is going to be the base of our thing here. So now let's add the internal documentation. So import. What this does is it returns a value. So we're not setting any variable to it. It simply returns the value. So if we use it, it's going to print whatever the result of this. So let's make it easily readable. So let's use an f string and encase it in curly braces. So the area of a small 10-inch pizza is area 13 square inches. And lastly, we don't want it to display this long, so we're going to make it colon dot 2f, so it stops at 2 decimal places. You might be interested in assigning a variable so it's easy for you to chart. So instead of return, I'm going to assign value is equal to math.py and then return the value. The return value should also be indented. We start with main instead of the typical start. So next we import math. So this is a process. It's represented by a rectangle. Next, we have to define the area with its parameter diameter. Compute the value as this: math.pi times half of the diameter squared. And then we return the value. So since we printed it directly here, um, instead of using just the print, we need to call the area. So before we can print it 4 times, we need to call it first. Call area 10, area 13, area 15, and area 18. And then you have to print it. So it's up to you how many boxes you're going to use for this. Sometimes you can use shortcuts like this. You can put them all in one box. But if you're expected to have individual boxes, then do so. This is the gist of number 10. You need to separate main and the area diameter. So that's all for today. So remember the best practices for programming. First of all, include internal comments to explain what you're doing. Always follow the syntax. Don't forget the parentheses, the colons, and even the quotation marks. And what else? You need to make sure that if you're going to flowchart your code, that it is easily flowchartable. So otherwise, you can just take shortcuts like this, like return math.py times the diameter. And then for printing, you can use f strings to print to keep your code clean. So even if you want to do your computations inside the f strings, it's okay. You can just call the function. But when flowcharting, make sure that you separate them. Also, for flowcharting, make sure that all of the decisions are labeled with true or false. They split the flow lines when going into separate computations, but then they have to come back into one line for the end of the code. So um, there are different structures for each of them. So just make sure that the one you're using makes sense. So for example, this is not a standard shape of a structure, but it's still clean to look at. So always double check where your code is going and make sure nothing is being skipped on by accident. So that's all for this video. I hope this video helped with your studies. So thank you so much and good luck.